I used to ride around with MapQuest. Before I left my house, I'd print out the map, and I was the only one in the car driving somewhere for work, and I'd try to drive and look at the map at the same time, and then I'd miss the exit, and I'd go 10 miles past where I needed to turn and go back around, and about an hour and a half later, I would eventually end up where I was going. And my wife and I were visiting some friends one day, and we had gotten there by MapQuest, and they had a GPS unit, and they let us borrow it to go somewhere. And we put it on the dashboard, and it just showed us the picture, and it gave us directions turn by turn, and I didn't have to pull out a map, and I didn't have to try to do 3 things at one time. I could just focus on driving, and it would tell me exactly where to go and how many feet I had before my next turn, and we were wowed. I think we probably bought a GPS unit on the way back home. We were amazed. Well, that's an example of AI because no one programs every destination and every point of origin that you're going to take in order to use GPS. The GPS unit just needs to be able to start with wherever you're starting and go wherever you want to go, even if it's a new address. Even if that address did not at first exist, it just needs to be able to figure it out. And that's an example of a type of AI that is called machine learning. It is trained on patterns, how to get from point A to point B most efficiently, and it can then find similar kind of patterns even if it has different situations to deal with. And that's the beauty of it. The question is, does GPS actually know anything? Does it know where it's going? So the most engineering experts will tell us, no, the GPS does not know anything. It doesn't know where it's going, just as my watch doesn't know what time it is. It just tells what time it is, but it doesn't actually know anything. That's what most of the experts would tell us, okay? And yet, that doesn't stop us from listening to the GPS. People have actually followed GPS into a lake. They've turned into a blind alley because they trust it so much. You know, it must be right. Well, this says one way. I know, but the GPS said to go this way, so I'm going to do it anyhow. That people have this ability to trust the machines, even though we may or may not be able to tell whether it knows anything. That process, though, the reason why experts say your GPS can't know anything is because it's a machine, and it's literally doing math. And they'd say that's not the same thing as knowledge, all right? So I'm gonna explain to you an example of that's machine learning. I'm gonna explain to you human learning. A child learning to speak. Parents are very excited. And the parents hold up an apple because they want to teach the kid the word apple. So they hold it up, and what does the parent do? They say the word apple. Right? And the child sees the apple, but the child also hears the word apple. And eventually, the child learns that what the parent is holding up is an apple, and the child will eventually say apple. But even before they can speak, they see it, they hear it, they make that connection. Now, and we say they've learned the word, okay? So what's literally going on? Well, at least physically what's going on is that the brain cells associated with vision are getting stimulated. That means they're experiencing an electrical pattern, electrical excitement, when the parent holds up the apple. And other cells somewhere else in a different region of the brain associated with hearing light up. They get excited, meaning they experience electrical pattern when the parent says the word apple. So in one region of the brain, there are cells that experience a pattern, an electrical pattern. They light up at the sight of this object, and somewhere else in the brain, a different groups of cells light up in hearing that word, because there's vision and there's hearing, and those are 2 different processes, and those are 2 different communities of cells. But because they're happening at the same time, those different communities start to build a connection, a physical connection between each other. And as those communities of cells build connections, and the parents keep saying apple, more connections get built, the connections get stronger, so that when one group of cells light up, the other group of cells light up. So when the child sees apple, the cells associated with hearing the word also light up because now they have a physical connection. Learning is a physical connection. That's what that is. It is a physical connection between different communities of cells. AI does something similar mathematically, because there are no cells, it's software. But there are different computations in that software that start to get associated with one another so that machines can pick out patterns in one set of data and find something else. And the child starts to pick out patterns. They know that these things go together and they can learn other fruits, bananas or whatever. This is why if you've ever eaten something on a flight and the flight was bumpy and you got nauseous and you were eating, I don't know, pickle salad, and it tasted great at first and then you got nauseous, the next time you see or smell pickle salad, you will get nauseous. And it's because your nauseating cells were getting stimulated at the same time that you were eating that salad, and they formed a physical connection. And now they're stimulating each other. So that's learning. Okay, that's the physiology of learning. So if that's happening with humans, if that's how we learn, and if that's what's giving us this ability physiologically to experience learning, if it is a physical process that makes that possible, how confident are we in saying, sure, we figured out what's going on with these brains, we know that these neural connections are happening, but there is something else in addition to these physical things that are allowing us to experience this knowledge. So I'll come back to that, okay?